Good afternoon. Thank you, Engineers Welfare Forum, WBPDCL. We have heard a lot about applications of artificial intelligence in power system. So let me say, what is power system? It involves generation, transmission and distribution. Till date, in most of the cases, we see generation is remotely located bulk power stations, be it thermal, coal or gas, then large hydro stations, nuclear stations. Then those are power is emanating from these stations through long transmission lines, whether it is 132 kV or 220 kV, 400 kV or 765 kV in our country. Then there is distribution system to supply the retail customers, industrial, domestic or commercial customers. However, as per our Electricity Act, though there is nothing such thing that yes, 132 or 220 kV can also be a part of distribution system. What we see in CESC's distribution system, but generally 33 kV and below is part of distribution system. Now, applications of AI in generation we have heard of. One area which we can think of seriously about fuel management, because you see, for thermal power stations, fuel is the single most cost component. Not only thermal power stations, if we look at the entire power system, that is the single most highest component so far as cost is concerned. Then in transmission, see asset management, there could be vegetation management, could be so many areas. Now in distribution, see, there are many challenges, and it is the most challenging area in entire power system chain. So the success of entire power system depends on distribution. You see, money is collected from distribution. Challenges are many. Some of the major challenges is reduction of distribution losses. Throughout the country, this is the biggest threat for distribution business. Then managing cost for power procurement. You see, out of 100% of average tariff that the consumers pay, 70 to 80% goes to power procurement. So if we want to manage the tariff of retail consumers, then managing power procurement cost is most important. Then providing quality power supply. Quality means less interruptions. Quality means good voltage band, not much distortion. Thank you. Not much distortion. Distortion means less harmonics. We want less harmonics in voltages. And most important is meeting customer expectations, whether it regards to supply or it regards to billing. So these are the challenges, and we understand that artificial intelligence can play a big role to mitigate all such issues. But though I have said about the power flow from big generating stations to distribution through transmission system and ultimately from distribution to consumers, but things are changing quite fast. On your right, you see things are changing. Now this small scale generation is coming up. Solar is coming up in small scale rapidly. Recently, Government of India has taken up initiative for solar in households. So 1 crore household will be electrified through small solar plants. Pradhan Mantri Surya Ghar Yojana. You see, 1 crore means it's quite a large number. Total capacity, if you see, some gigawatt scale. Then microgrids are coming up. Then EV charging. Maybe in future, not only charging the EV, maybe vehicle to grid. Vehicle will also supply power to the grid. So these probabilities are there. These are not new. In some of the advanced countries, already things are happening. In our countries, it is happening. We are testing. In some part, it is under R&D. In CSC, there are tests about microgrid application, then battery energy storage systems. All we see in near future. Now, there are many applications. One is load forecasting. So, load forecasting is very important for a distribution utility. See, you see, load is uncontrollable. We don't know when consumers will switch on or switch off. Load is uncontrollable. But till that, generation is uncontrollable. Generating stations, they are asked to follow the load. You see, the dispatch center, they put the directions to the generating stations to increase or decrease the load. But nowadays, renewables are coming up in a big way, and majority of such renewables, solar and wind, those are not controllable, uncontrollable, and these are termed as must run station. When sun is there, it will generate. When wind is there, it will generate. Now both sides, generation as well as load, both sides are becoming uncontrollable. We have to have a right prediction for generation, be it solar or wind, as well as load. And applications of AI in this area is a must. Then grid operation optimization, distribution loss in distribution loss control. So AI applications are many. So we can predict or we can assess the patterns. Then predictive maintenance of assets, improved customer services, energy management systems, smart grid coming up, management, then of course integration, as I say. So these are the areas, primary area, there could be many more. So as I said, that RE growth is immense. So solar and wind is coming up heavily. So this is the portion how solar and wind, you see, most of the RE is solar and wind, and this is the pattern how solar generates or wind generates. So it is highly unpredictable. Of course, in some part of the year during winter, so we can have some good prediction, but otherwise, particularly during monsoon season, it's very difficult to predict. Now, balancing demand and supply is most important. You see, a distribution utility, when takes power from the grid, the power, that cost of that power may vary from 0 paisa to 24 rupees depending on condition of, market, depending on market as well as frequency of the grid. So if we have right kind of prediction, then we can manage. When power price is low, we can take more power. When power price is high, we can take less power than our schedule. Thereby we can manage cost. So managing this supply and demand is of highest importance for a distribution utility. So predictive in many areas, in switchgear, in vegetation management, in transformers, in distribution transformers or power transformers. Then energy theft through the analysis. You see, now we are using more and more smart meters. Earlier we used to take just one reading for small retail consumers. For larger we take another 2 or 3 readings in a month. But now with smart meters we are having every half an hour data, voltage, current, power. You see the large volume of data we are having with smart meters. What to do with smart meters? So we can use AI to analyze this data for the betterment of customer services as well as improving financial results of the company. So workforce management, that is one area we can utilize AI for this purpose. So with smart meter, with workforce management, you see, before a consumer complain about interruption, distribution utility can send its personnel to rectify the problem. Then advanced smart meter, it is now again in our country we have a plan for replacing the existing 25 crore smart meter, 250 million crore existing meters with smart meters. Now huge volume of data, all kind of analytics we can do with such meters, and we need big data, thick data, whatever. And also in this control center applications, now we hear about lot of AI applications like chat grid, then grid GPT, e-grid GPT, and the big laboratories NREL, and so many they are involved. Universities, they are involved in developing such AI applications for power system. Challenges are there, challenges are many. One challenge is of course upfront cost. As I said, smart meter implementation, it is a huge cost. You see, normal vanilla meter, if it takes about say 1000 rupees, so you see smart meter, it costs anything between 7,000 to 10,000. So cost is an important. If we want to implement the smart metering, then AI, the cost is a big concern. Then availability of skilled force. So in electricity in industry, we don't see much of students from computer science, so having knowledge about AI and all other things, communication, etc. So we need more and more such persons having knowledge about computer applications. Then of course it will enhance operational efficiency, then financial conditions will improve, and we are waiting for more and more applications of this artificial intelligence in electricity distribution system throughout the country. Thank you.